Hi, everybody. Thought I would continue this series of working through the direction of bias in the omitted variable bias case. So now we're going to look at some cases where we have a negative underlying coefficient, a negative true coefficient. So the example we'll use is one that we've used in a variety of uh, occasions, and it's an example that Stock and Watson use in their textbook Introduction to Econometrics, and that's the test score and student-teacher ratio equation. So we have outcome variable is the test score in school district, and the explanatory variable is the student-teacher ratio. We imagine we have a sample of school districts around, say, California or across the country, and the larger class sizes are, class size and student-teacher ratio are basically the same thing, right? Students per teacher is class size. So the larger is the class size, the lower is the test score on standardized tests. We imagine high school or elementary school, right? So the higher is the student-teacher ratio, the lower would be the test score because with lots of kids in the classroom, the teacher can't devote individual attention to the kids. They don't learn as much. So that's our general model, right? With our error term encompasses other factors that might be influencing test score. Our coefficient beta 1 hat will be biased if some of those other factors, or at least one of those other factors, which we'll sometimes call a variable z, if that other factor is correlated with the student-teacher ratio and also affects the test score directly. So we have to ask ourselves, can we think of an omitted variable? Can we think of a omitted variable z that passes the two-part test, that it's correlated with the student-teacher ratio, and that also affects the outcome? Well, let's think, for example, in California, we definitely think that since immigrants vary widely from school district to school district, and many immigrants to California are not native speakers of English, that we might imagine, and they settle probably in poorer places because that's where rents are cheaper, and immigrants on average to California are poorer than other than native populations. So immigrants come and settle in places that are poorer on average than other places. Those places might have high class size, high student-teacher ratios. So there's a positive correlation between immigrants percent in the population or the students and the student-teacher ratio. And we might imagine that more immigrants in a school district means on average lower test scores because the kids are less likely to be native English speakers. They're more likely to be English language learners, and the test is in English, so they're going to do less well on the test, certainly in elementary school when they're still struggling to master English. So that's our two-part test, and sounds reasonable to me. So we would then say our expected value of the estimated coefficient, it will not be equal to the true coefficient. We'll have a biased coefficient. That's what we would expect. Now we ask, what's the direction of the bias? To think about that question, we can imagine that the true relationship looks like this, a negative relationship, and that's our true slope. And then we ask, what would be the nature of the errors here if there is indeed an omitted variable? Well, if there's an omitted variable, that is the percent immigrants in the school district. For districts that have high student-teacher ratios, they have lots of immigrants, and the immigrant kids don't speak English that well, and so they do worse on the test, right? So we're going to have errors that are going to be predominantly negative for the high student-teacher ratio school districts. For the low student-teacher ratio school districts, we have very few immigrants, and so kids are mostly English, native English speakers, so they do better on the test because they're native English speakers on average, right? So that'll be the nature of the errors. So that means that our estimated coefficient will be the best fit line through these errors, right? So we'll have a slope like that. That'll be our estimated relationship, beta 1 hat. And we can easily see that here it's a negative coefficient, so we should talk about the absolute value. The absolute value of this negative coefficient, right, will be bigger the estimated beta 1 hat will be bigger than in absolute value than the true beta 1 hat. That is, the relationship will seem steeper. It'll look like student teacher ratio matters a lot for test scores, but that it looks like that because underneath the surface there's an omitted variable, right? And the places with high student teacher ratios are also the places with lots of immigrants. So it's having lots of immigrants that's pulling down their test scores, not the student teacher ratio so much, right? So our bias then works that way. Pretty reasonable, pretty easy to figure out. Let's do another case. So let's imagine that now we have a situation where we have a omitted variable z, and that's rich kids have a lot of mental health issues. So let's imagine that rich kids, kids who are in school districts that are very wealthy, their parents are pressuring them a lot. Their parents are workaholics. They are growing up, being shuttled between activity to activity, and so they end up having a lot of mental health issues. One could imagine, right? So now we have a correlation between rich kids and student teacher ratio. So we imagine that places with really small student teacher ratios are the places where there's lots of rich kids. The parents in those districts are lobbying I want my kid to be in a small class size. How dare you put my kid in a class size that's bigger than 12 students in the classroom, right? So the correlation there is negative. The more rich kids there are, the smaller is the student teacher ratio. But the more rich kids there are leads to lower test scores because rich kids have a lot of mental health challenges, right? That maybe middle income kids or poor kids don't have. They don't have the same degree of expectations, tiger moms, or whatever, all those stress-inducing things that one reads about in the newspaper. So again, all this has to do is be plausible. We could debate about, are there enough kids like that to make a difference on average, right? California is a big state. Maybe there's two or three school districts where that might be a problem. But right now we're just in the is it theoretically possible, right? We're at the plausible, maybe theoretically possible, certainly. So that's our two-part test, right? And this omitted variable certainly passes that test. So now we think about the direction of the bias. We imagine our true relationship is this, but now the places with very small student-teacher ratios, right, with small class sizes, these are the places with a lot of rich kids with mental health issues so they don't perform that well on the test, right? Because they're too stressed out to perform well on the test. So the errors are on average negative in the small student teacher ratio districts. In the high student teacher ratio districts, these are places where you don't have any of these stressed out mental health challenged students, and so kids on average perform better because they're more balanced in their mental health stuff, right? So now we can see what our estimated coefficient that best fits the scatter plot would be, and we see it has a flatter slope. That is, the absolute value of our estimated beta 1 hat would be less than the absolute value of our beta 1 true. It's a flatter slope. That is, it'll look like student teacher ratio doesn't matter very much. And the reason it looks like that is because in the small class size places, they have low test scores for a different reason, for another reason, because they have a lot of stressed out rich kids who don't do well on the test. Whereas in the high student teacher ratio classes, there's all the kids are balanced and well adjusted, and thus they perform better on the test than they would otherwise. So it looks like student teacher ratio doesn't matter very much for test scores, but we know the underlying relationship is indeed a negative relationship. So we can see the direction of the bias that way. So hopefully this will be helpful. You should start working on your own possible regressions and omitted variables and working through the direction of the bias that way.